What if the invisible force holding the universe together simply disappeared? No alarm, no warning, just a silent vanishing of the cosmic glue itself. Look at those stars twinkling, the planets shining bright, and that amazing swirl of the Milky Way lighting up the night sky. But what if I told you that everything we see, everything we've ever known, is just the tip of the cosmic iceberg? About 85% of the matter in our universe is something we can't see, touch, or detect directly. Dark matter is like the universe's secret glue, keeping galaxies all snug in together. But what would happen if it all just disappeared? In an instant, poof, gone. Let's imagine it. Right now, this very second, all dark matter across the entire cosmos vanishes. For the first few moments, on Earth, you wouldn't notice a thing. The sun would still be shining, your coffee would still be hot. But out in the vastness of space, the most spectacular and terrifying cosmic unraveling would have already begun. The first victims would be the galaxies themselves. Our own Milky Way galaxy, for example, is spinning much faster than it should, based on the gravity of all the visible stars and gas. The outer stars should be flung off into the void, like kids flying off a merry-go-round that's spinning too fast. The only reason they're not is the immense gravitational pull of a massive, invisible halo of dark matter surrounding our galaxy. Without that dark matter halo, the chaos begins. Stars on the outer edges of the Milky Way, no longer bound by that extra gravity, would start to drift away. They wouldn't shoot out like bullets, but they would begin a slow, inexorable journey into the lonely darkness of intergalactic space. Over thousands and millions of years, our beautiful, tightly wound spiral galaxy would start to come undone. It would expand, lose its shape, and become a diffuse, disorganized collection of stars. Imagine a dandelion puff caught in a gentle breeze. That's our galaxy, slowly disintegrating, and we're not alone. This would be happening to virtually every galaxy in the universe. Spiral galaxies would unspool. Elliptical galaxies would puff up and bloat outwards. The cosmic web, the grand structure of the universe where galaxies are arranged in long filaments and clusters, would begin to dissolve. This web is held together primarily by the gravity of dark matter. Without it, the threads would snap. Galaxy clusters, some containing thousands of individual galaxies, all dancing around a common center of gravity, would be the next to go. These clusters are like cosmic megacities, with dark matter acting as their gravitational mayor, pulling everything together. With the mayor gone, there's no authority. The galaxies, which are already moving at incredible speeds within the cluster, would no longer be gravitationally bound. They zipped past each other one last time, sharing a fleeting moment before moving on. The universe's largest structures would simply evaporate into a thin, uniform soup of solitary galaxies and homeless stars. The night sky, viewed from any planet millions of years in the future, would become a much emptier, much lonelier place. But let's bring it back home. What about our solar system? Would Earth be okay? The good news is, probably yes, at least for a while. The amount of dark matter within our solar system is thought to be incredibly small. The orbits of the planets, including Earth's orbit around the Sun, are almost entirely dictated by the Sun's gravity. So, we wouldn't fly off into space. Life would continue, seemingly as normal. However, we wouldn't be completely unaffected. Our entire solar system is on a grand tour of the Milky Way, orbiting the galactic center once every 230 million years. This path is determined by the total mass of the galaxy, including all that now missing dark matter. With a significant portion of the galaxy's mass suddenly gone, its gravitational pull would weaken. So, picture this. If that happens, our solar system's orbit would totally shift. It would stretch out, and we'd start drifting away from the heart of our galaxy. How wild is that? This isn't an immediate catastrophe, but it could have long-term consequences. As our solar system moves into new, uncharted regions of the galaxy, we could be exposed to different levels of cosmic radiation or have a higher chance of close encounters with other stars or rogue planets. The stable, predictable path we've enjoyed for billions of years would be over. But there's an even more fundamental, and perhaps more profound, consequence of dark matter's disappearance. It goes back to the very beginning of the universe. How did we even get here in the first place? How did the first stars and galaxies form? The answer, once again, is dark matter. In the early universe, after the Big Bang, everything was a hot, dense soup of particles and radiation. Normal matter, the stuff that makes us who we are, was getting tossed around by super intense radiation. It was tough for it to clump together and form anything under its own gravity. But dark matter was different. It doesn't interact with light or radiation, so it was free to start clumping together much earlier. These early clumps of dark matter acted as gravitational seeds. They made these super strong gravity wells that sucked in all the gas and dust around them. In these dark matter cradles, the very first stars lit up, and galaxies began to form, creating the universe we know today. Without dark matter, these seeds would never have existed. The clumping of normal matter would have been way less efficient. Right. Seriously, it would have taken ages for gravity to pull anything together and form structures. If dark matter had never existed at all, the universe today would be a radically different place. It might just be a cold, dark, and mostly empty expanse, filled with a thin, uniform fog of hydrogen and helium. No galaxies, no stars, no planets, and therefore, no us. The disappearance of dark matter asterisk. Now asterisk would unravel the universe, but its absence from the beginning would have meant the universe as we know it would never have been woven together in the first place. When dark matter just disappears, the effects at first are pretty low-key, but trust me, the long-term picture isn't pretty. Our galaxy starts drifting apart, and those massive cosmic structures we love, they slowly fall apart too. It's wild to think about. The universe becomes a more chaotic, and ultimately, a more desolate place. It's a stark reminder that the visible world is built upon an invisible foundation. This invisible substance, this ghost in the cosmic machine, isn't just some strange, exotic theory. It's essential. Its gravity governs the dance of galaxies, nurtures the birth of stars, and sculpts the very fabric of the cosmos. Its sudden absence would be like removing the laws of physics that hold our reality together. The universe wouldn't just be different, it would be fundamentally broken. So the next time you look up at the stars, remember the unseen. Remember the 85% of matter that's silently holding it all together. Be grateful for the dark matter, the universe's quiet guardian, whose presence allows for the beauty. It's all about the layers and twists in life, right? Without them, everything would just fade away quietly. Thank you so much for joining me on this cosmic journey today. If you enjoyed unraveling the universe with me, please hit that like button and consider subscribing for more deep dives into the mysteries of space. Let me know in the comments what other cosmic what-ifs you'd like to explore. Until next time, stay curious.